şey yapsana.
الفيديو
والله
هذا رينج روح.
Here is our mechanical laboratory. We can make mechanical tests here. We have here some accreditation. We have the accreditation for some of the parts. Here it's for strain, and also the compressive strain, tensile strain, all mechanical tensile strain. This one is for fatigue test. So we can give, for example, here
This can use it in steel factory.
in steel factory, or also,
Yes.
for example, we are working on some shock absorber. In shock absorber, we use also here. We can connect here, and for example, we can use up to 10 ton, 100 kilonewton. So we can compress and tensile stress, and we can also control the frequency. We can go up to 50 frequency, but if the loading is too high, we decrease to 1-2 hertz, and but we can go up to 50 hertz. This one is for hardness testing. This one for Vickers, Brinell, and the Vickers test, Vickers HV, hardness Vickers, hardness Brinell on a Rockwell. And this one is optic emission spectroscopy. It's for metallic part. If you want to see the composition of metals, chemical composition of steel, copper,
How
tin.
many items?
We have six items: iron, copper, zinc.
Carbon.
With iron, we can see the carbon.
Carbon.
Carbon inside the iron. We have cobalt, nickel, cobalt, aluminium, magnesium. So for all this kind of alloys, we can see the chemical composition inside.
By nitrogen.
It?
Nitrogen work by nitrogen.
Yeah, it's working. The gas is there.
Yes.
So
Nitrogen make spark.
it's park, yes, here.
Okay.
We clean, and after that we can see. If we need, for example, to prepare some samples, for example here, polishing, cutting, or electro-polishing for surface cleaning, or if we want also for laser, working with under laser, plasma.
Yeah.
And we have here, for example, optical microscope, usually for metallographic analysis. For grain size, the inside, if there is ferrite, cementite.
It's inside cracks.
Yes, cracks.
Yeah.
And also the grain, number of grain and so on, because it's very important in forecasting iron.
Also see gases.
If,
Inside oxygen.
yes, we can see also this. If we have some pores due to gas.
Yes, because from iron to steel make vacuum.
Yes, yes.
Yes.
If you need stainless steel,
Stainless steel make vacuum.
like we need by vacuum, yes.
الحديد تاعي.
This one, it's one of the research laboratory. It's here for energy. You can see for here for more for solar cell, because we have solar cell simulator. For solar cell simulator. Yeah, for photovoltaic. And PV, for PV. For PV.
Solar.
For solar. Also, we have the other optical analysis we can do here. Here we have Hall effect. if we need electronic measurement of materials, how many electron, how many hole for connecting. The battery
video.
electrochemical
Good.
test and so on. So if we need to determine the potentiostat we say. So if here it's for electrochemical and energy. Now, this one also for production. This is our globos. If we need to work on the argon without oxygen, without clear area, without oxygen, without humidity, no moisture here inside. And we can make, for example, for thin film production, atomic layer deposition, or fiber, electrofiber, and ultrasonic, this one is for viscosity. This one is spray pyrolysis if we want to make with ultrasonic some small particle, nanoparticle, with sonication, yes.
The person is still like behind, can see.
It's more for example, you have a solution, and when you make the ultrasonic part here, the solution become like fume solution. So you have a small particle, and you can keep it in water or in other solvent to have small particles.
Small body.
This one is for when you prepare the PV solar cell.
Solar.
What we say, Dr. Blade. So, for example, here you say this one it's silver.
Yeah.
You know silver is it's one of the main famous now because we for the PV you need lot of silver. Imagine for each cell you need all this silver. So silver it's very. So if you have silver in your minds, I advise you to take care.
Silver, but less.
Because you need mineral, yes, little bit. But that it's
barriers need 10 kilo. Not more.
that's all.
Main is gold.
Gold. Okay, gold is still okay. Gold is okay too. Okay. This one of our research laboratory. Yes.
This is rejected.
For research, here is for research. But for analysis, another research laboratory. For analysis, here we have materials. This one is for so we can give the samples up to 1,600 and under argon, azote, argon, nitrogen, oxygen, or under carbon dioxide, and we see the mass change if it's mass loss, or if the mass is increasing according to the atmosphere and the temperature. For example, when maybe sometimes
Go up.
now for mineral yakıyorduk ya hocam mineral.
Roasting.
For roasting, yeah. If, for example, if you make roasting in your compounds, in your raw material, so will it takes mass or will it lose mass? Because sometimes there are oxidation, so they take oxidation and the mass is increasing.
Yes.
And sometimes it lost. For example, if you have calcite, you will lose carbon dioxide, and when you lost carbon dioxide, you will see the mass is decreasing. And it's important for us because we see if at which temperature there is the change of mass or the change of heat also we can follow. Sometimes you have just allotropic fast transition, so one solid become another solid. So we can see also here at which temperature there is the change of this phase.
To keep it under this degrees.
Yes, and we can see we have to hit at least up this temperature, or we have to keep under this temperature according what we need.
Yes.
Here it's for more for polymeric materials. for example, now we are working for caoutchouc, rubber, and for rubber, at which temperature the rubber start to be soft, because it is solid and it can break. It can break under temperature under 60 minus 60. But after 150 or 120, it start also to
Make it easy.
to crash and so on. So when we can see at which temperature, and also what is the load that it can resist.
Yes, resisted, yes. And working area.
Yeah, and we will see the working area.
Working area.
Because now, for example, I'm working with this company. It's Iranian company here in Turkey, and they are making some bumper for a big machine,
Big truck.
big trucks, suspension also, suspension also for the dumper.
Number,
Yes. So for bridge also we can work, and so we know at which load it can resist and under which temperature it can work. So if they want to send the suspension to Russia, or if they want to send the suspension
Sudan.
to Sudan, you know, it's minus 40 or 30 and maybe 40 or 50 in desert. So we need to see if the rubber will resist or not.
It's analysis.
And we can go by this way. And this one is for density.
Density, yes.
Step density and helium picnometer. And I heard this morning in the information that helium will be a big problem.
Yes.
Because Iran is striking Saudi Arabia this morning, and it is one of the biggest helium production center in the world. So we will have some problem with helium. So this bottle is very it's very expensive now.
Helyum üretim tesisini mi vurmuşlar? İran'daki mi?
İran şeydekinde, Suudi Arabistan'daki.
Suriye Arabistan.
Yesterday, petrokimya in Iran.
En iyi.
Today Iran
Saudi Arabistan.
Saudi Arabia.
Hiçbir şey yok. Allah korusun.
Hocam helyumsuz kaldık mı çok şey kalacak.
Ya evet helyum. Argon o işi görmüyor o zaman.
Evet. Yeterince bilmiyorum.
Evet.
It's our display diffraction for powder, for film, and so on. So when we have the sample here, and we can get this kind of diffractometer, maybe you know, and according to the peaks, we can know which phases are in the sample. So if we have metallic gold, or if we have gold with another compounds, or if you have iron, I don't know, if you have copper, and so on, which phase we have, we can see here, we can determine here. And according to this one, we can start to think about your process.
How to remove it.
Yeah, how to remove it, or for example, we are working with Salih Hocam, we work on pyrite. So there are some gold inside the pyrite, and our goal was how to remove or how to destroy the pyrite structure, but without destroying without losing gold. No heating, because if we heat, we have some sulfide oxide and so on, and we are working on this process.
When you use physical, when you use chemical.
Yes. And which chemical, which physical, which is the highest temperature that we have, we can reach, not more, because it start to pollute environment or atmosphere, or maybe in company it will make some
Maybe
problem.
you make high, take the gold also again.
And that's what and leave to waste and so on. So the analysis is very important to determine the process.
حرارة الدائرة الاستزادة. طبعا والله شغلت بداية الفايل.
Here for more particle size. So for example, if you have your molecules, so you have the sieving way with the sieves, and you show me. But this one it's more precise. Like you can see up to few micron or nanometer to few millimeter, and they say what is the rate and so on. In few minutes, we can see the particle size distribution. So the sieves is very important in
Because
in
example
the field.
you,
Yeah. But it's yours, your system. We have also here in the other laboratory. We have also the same system, but this is one is better when we have big amount of minerals.
yes.
Or if your ores is very important, but if we have small materials, we can see also here.
Was this aqua?
We can work it with a liquid system, in liquid system, and this was in a dry system. Direkt both are present here.
Sizde PET var mı hocam? Şu
Ha?
karbon, aktif karbon yüzey alanını şey yapar.
Var.
Var mı?
Var. This is nanosizer. It's for the smallest, and in this one we can also see why you say the zeta potential. Maybe I don't know if you know this.
For
And
flotation.
For
do you know?
flotation, you need.
Hı hı. Zeta potential.
For zeta potential, we can see here, and here the contact angle. So if there is some hydrophobic or hydrophilic properties in one material, we have the contact angle. So it's if we need for water, we just put the water here, and when we put the drop of water on the surface, we can see if the surface is hydrophilic or hydrophobic, and which is the contact.
Contact angle
Mhm.
determination.
Surface, yes.
And
On the
contact
surface.
angle
So if
determination.
it's not water, maybe we can put oil, we can put alcohol, we can put acetone, and whatever. Some
There's huge differences.
any liquid, we can use it here. Okay, go down. I will show you our.
After we have problem in flow. In flow all time, flow accounting.
Mhm.
All time we can use different device or meters.
Mhm.
But they give us different readings.
Yes, but usually in some experiments we have to make several multiple tests
Yes.
and have to take the average value.
Yes, all time like this.
Yes.
But if you in Turkish you find accurate device for meters.
Or flow meters.
Because gold is any different reading is very serious.
Yeah.
You send
I
here,
have to think about it.
Yes.
Here we have kolay gelsin. Our scanning electron microscope. So we can go up to 10,000, 20,000 magnification. And we have also EDX, energy dispersive analysis. So if you have a sample, and on this sample you can see the morphology up to 20,000, this one, 1 billion, 1 million in the other, but this one is 20,000. And we have also the mapping of elements inside the material. So, for example, if we have gold and we are sure to have gold in one, for example, small part or a small rock, we can put the rock inside and see if the gold is outside or inside, and which kind of element, how the element is how to get it,
To
but
decide size of diameters of
yeah, we can see also.
16 or 18 or
Yeah, we can
or
see.
micron.
Yes,
Yeah.
in below micron, we can, for the other one, we can go down to nanometer. In this one, 100 nanometer, but the other one, down to nanometer. I can show you, it's the other one. Kolay gelsin Akın.
Tekrar kolay gelsin.
She is our vice director here. And she's also working with, she both are down this device. This device is the, how we can say, the Ferrari or Lamborghini.
Yeah.
The other one is a small car, Volkswagen. This
Volkswagen.
one is Lamborghini.
Yeah.
There are just three devices like this one in Turkey. And in ours, we have also here the mapping. We have also the EBST, if we want to see the crystal distribution inside the sample. And we can go up to 1 million magnification. It's very important.
0.7 millimeter resolution.
0.7 nanometer.
Yes, less than 1 nanometer, we can see. But if we want to see, well, no need. For you, no need.
Nanometric size.
For you, no
You
need.
make it for test and how to make it to production.
No, you cannot. But if you are working in electronic,
Yeah,
So
so
you
you
need-
need, yes.
so and we have to offer service to everyone.
Yeah.
So she's working in, and the only things it's when you use this device, as much as your sample is conductive, as much you will have a good pictures.
Be careful. Any element inside.
Of course. Any impurities you will see directly if there is any problem.
Kolay gelsin.
We have also, I will show you some things here, also for surface. For surface here, we have this one, it's non-indentation. If we have one part, we can see the hardness of local hardness on the surface.
Yeah.
So for example, for mining, if we need, you have rock, you will
Yes.
cut it
Yes.
and polish. After that, when it's polished, if you have some different crystal, you can, if you don't know which crystal it is, we can see by the hardness of the crystal. What is the distribution
Yes.
of the hardness? And we have mapping of hardness.
Yes, make mark.
Harness.
Mapping of hardness we can see. This one is optical surface morphology. So we used to work with them when we have some coin, you can see the surface, or when you cut some things, it looks very shiny and you say it's homogeneous. When you put here, you see that it's not homogeneous. There are some peak and valley and so on.
I'm using this for wall. You can take the last. Yes, you can find some different.
The surface roughness.
Not wrong, but chemical is different.
Here you can see this one with or with EBST here. Because you will see there are some crystal like this one, but others like this one, others like this one, so you can see that the grain size
All
also.
surface.
Let's go success. Make it should be like this.
Hardness more than 7.
Hmm.
More than 7 more.
More than 70 roughness.
More.
So, and this atomic force microscope is also for electronics. No need for you. It's too sensitive for you.
But for researching is necessary.
Yes, for research is necessary, of course. Here, when we are working with the very sensitive, we put this machine here because we are close to the soil and there is no vibration. Below it's rock. Below this building is rock. So now we are closest as possible to the rock. Can you go? That's it.
Video betul kami rumah terus tetap.